All right, guys, so welcome once again to my Web3Bridge series. So this part of my weekly review of my activity in the Web3Bridge house. So in this week, we delve into ERC-20 tokens, factory contracts, and the rest. So in this series, I'm going to teach you how to build ERC-20 token from scratch using the official documentation. So first of all, I'll show you how to build it from scratch. Then I will go back, explain the code line by line so that you actually understand what's going on under the hood. Then, we now take it to Remix. So in Remix, we now deploy it and test to see that, okay, all we've said, all we've defined, and everything works as it should be. Now, for those of you who are so much interested in DeFi like me, so you are going to, ERC-20 is what you should know to the core. It's what you should know to the core, you get. So, and I feel great, you get. I feel blessed to have you around. So I believe to give you the best. I believe to give you the best explanation I can. So join me as I walk you through how you create this awesome token from scratch. So let me bring up my dev environment. All right, so let me get my terminal. So first thing I need to do is I want to create a folder. So let's say ERC-20 token from scratch. All right. So this is the folder I created. So let me go into this folder. So I want to open up this guy in my Visual Studio Code. Let me open it up in my Visual Studio Code. Sorry, that is code dot. All right, so why the Visual Studio Code is coming up? So okay, let's go to the official EIP documentation to see the methods we are supposed to implement based on the ERC-20 Token Standard. EIP.Ethereum. So this is the official ERC-20 token website. So let's go down to, let's look for ERC-20. Wait, let me just go back. Let me go to all. Yes, go down to ERC-20. Now this is the ERC-20. So this is known as the token standard. So it was proposed by Fabian and Vitalik. So first of all, why is this guy called ERC-20? Now, the reason why this particular ERC was given the number 20 was that when this proposal was brought up on the Ethereum GitHub and the Ethereum official community, so it has the issue number of 20. You know, GitHub, there's what we call issues. Yeah, when you create an issue, maybe you see something you want to work on or improve on, then you create an issue. So for this guy, it has an issue number 20. Yeah, I think, was it on November? Okay, so improvement proposal number 20. So this was proposed on this proposal was brought up on November 2015. Yes, so that's why it has why it has 20 to its name. Then if you can go to the official GitHub to see the issue and what was brought up during them. But that is that. So let me walk you through this to for you to actually understand what we are going to build. Yes, so we take it line by line, try to understand everything specified in this EIP. So EIP is Ethereum Improvement Proposal. Now, when an EIP has been passed and approved, then it turns to, you now have what we call ERC. You get ERC is Ethereum Request for Comments. So you can just see it as, okay, EIP is done at the protocol level, while EIP is done at the software level. So you can just take your time, go through this, yeah, but I want to go to, so you say no, the following specification, use syntax from, okay. So name, so one of the features you have in the standard is name. So this name is going to return or hold the token name, because when you are creating a token, your token must have a name. So it says here that it returns the name of the token. It returns the name of the token, example, my token. Now, it says that this guy is optional. Like, now, after creating this token contract, we're also going to create an interface for it. Now, this is telling you that, okay, if you want to create an interface for this guy, you might not actually need to bring in the name. So that is why it says it's optional. Okay, so what we do is we copy the name. Now it tells you that it returns string. And you know that in Solidity, we have various variable types. Okay, let's go back to our VS Code. Get, so let me just say ERC. Okay. Let's say mass token. Mass token dot so. Okay. So pragma solidity. So contracts, mass token. So this is how you define your contract. So let me zoom in. All right, so the first thing they ask us to implement is the token name. Yes, so it's the token name, and it tells you that it returns a string. It returns a string. So that means for it to return a string, that means you should have a variable that is already, that will store this token name, so that each time you call this function name, then you now be able to return the token name. So we are going to define a variable string. You can make it public or you can make it private. Yeah, but let's just make it public. Yeah, token name. So this variable token name you define here, from the standard, it says that it's going to return the token name. So that means we return token name here. Okay, this guy has to be in memory. So we've implemented, we've created a method that will actually help us to return the name of the token. As simple as that. So let's go back to the docs. Now the symbol, it says that the symbol returns the symbol of the token. Okay, when you have a token name, you now create a symbol. Symbol is just the let's say the shorter way of calling it, just like as we have mass tokens. So our symbol might just be MT or MIT, you get. So let me just copy this method and we improve more on it. So we have a function that's going to return string memory. So this guy is supposed to return the symbol. So that means we need to define a state variable. Yeah, a state variable that we hold this symbol so that once you call this function, it will be able to pick it up from the state. Now, in Solidity, we have the state variable, we have the local variable, and we have the global variable. So the state variable, they are stored directly on the blockchain. So they are stored on the world state, yes. So that means they are stored permanently on the blockchain. While local variable, they are not stored permanent, they are transient, so they are stored momentarily. So, and local variable, you always see it inside functions, but state variable is always outside of a function. So local variable means that once this function stop executing, the state of that particular variable is transient. So once the function stops executing, it doesn't stay anything again, get. But for state variable, they are still permanently on the chain, on the blockchain. So that's why it's always outside the function. Then we have the global variable. So the global variable, they help you to actually know the state of the blockchain. Yet, so these guys that are implemented at a protocol level. So you, the developer, you are not the one that define global level. They've already been implemented at the protocol level. So it's just for you to know them and how you assess them. So one of them you might be making use a lot as you build and develop is the MSG.sender, which is the call of. If you are calling this function symbol now, you are the MSG.sender, yes, or we have the MSG.value, which tells you the value of what you are sending or whatever, just the amount. So we are going to see how it works as we progress. Yes, so this is token symbol. So I'm returning this guy. I'm returning token symbol. All right. So that is that. So the next we need to return is the decimal. So it says that I return the number of decimal the token uses. Example, 8 means to divide the token amount by 1 into 80 to get user representation. So this method is optional. So if you are creating an interface, you might not actually need to bring in this decimal, you get, but let's write the contract first before we now build an interface for it. So we have the decimal, get, so since this guy is going to return the decimal, yes, so let's just create a state variable for it. You know, you can actually have code the decimal here, get, but for me, I feel like let's make it dynamic so that after building this contract, whoever has access to this contract wants to deploy it can actually bring in his or her own decimal. Also, that is the reason why we didn't we could actually just after defining the token name and the token symbol, we could actually assign it to name, you get. But I don't want to do that. I want it to be dynamic. Reason being that, okay, with this contract, if you are deploying it, can give you your name or whatever, you get. So we are going to create a function that is going to allow you to do that. So stay with me. Let's take it step by step. So this is decimal. So being a decimal, I mean that is a number. So it's going to take, it's going to be a unit. Yes. So let's make it public. We call it decimal. Yes. So I'm going to use what we call constructor function to initialize this guy. So it's going to return decimals, right? Okay. Okay, let me just change this naming. It returns the token decimal. All right. Return the token decimal. Token decimal. What is happening? Let me just copy this guy, Jerry. Don't type in, it's not possible. Okay, let's change the type. So it returns the token decimal to tell you how many decimal the token has. You get. Now I'm going to create a function we call constructor functions. So constructor, they are function that they are only run once during the contract initialization, during the contract deployment. So, and what constructor helps you to do is to initialize your state variable. So it helps you to set initial values for your state variable. Now, since I have this state variable here already, and I want to make them dynamic, so let me bring in a constructor so that I can actually accept input from the user. So those inputs I accept from the user will be automatically be transferred. Whenever you call the name, you get the name the user put. Whenever you call the symbol, you get the symbol the user put. Whenever you call the decimal, it gets the decimal the user puts. All right, so constructor, so let's underscore token name underscore token symbol. So we also need to define the data type, which is string. And you know, Solidity is a statically typed language. So that means at any time you are defining your variable, you need to state the type. Then you in 256 token decimal. So this is our constructor function that is going to take in 3 parameters upon deployment. So let's initialize the inputs we are getting from the user so that it will be stored to the state variables we have. So token decimal to token decimal, token name to underscore token name, then token symbol to underscore token symbol. All right, that is nice. So yeah, we need to actually, if you read the error now, it tells us that data location must be storage or memory for, okay, so we need to specify which data location we want these guys to take. So let's make it memory. So we've implemented the token name, token symbol, and token decimal. So let's go back to EIP to see what else we need to implement. Now we need to implement the total supply. So it returns the total supply of a token. So tokens always have total supply. So total supply is the total amount of the token that is available or that is minted. Yeah, so the total value. So since we are returning a total supply, so that means we still need to have a state variable that holds this total supply. So we create a state variable of 256. Okay, token total supply. Get so whenever this function is called, it's going to get whatever that is stored in this token total supply. Get so stay with me. I'm going to show us how when we start implementing the main function. So when you're meant, you send it to the total supply. You get so that is that about token total supply. So let's see, go back to the balance of. So it says that the balance of returns the account balance of an account with address owner. So what this is telling you is that whenever you call this function, I'm passing an address, it's going to return you the balance of that address. So once you call this function, it's taking in an address as a parameter. So once you call this function, it's going to return you the amount of this token, this particular address you are passing in has. Get so that's why you see that return type here is balanced. You get so now there's what we call mapping in Solidity. So mapping, so for those of you who are familiar with JavaScript, you get mapping is just like the way we have, in JavaScript, we have objects. So it's a key value kind of data structure. So given the key, you can actually get the value. So if you put in the key, in this case, since what they are requesting for a user to put in is the address, so that means the address is the key. So once you put in the address, you now see the value. Just like, take for instance, in your phone, if your phone is locked, so I need your password to be able to unlock your phone. Okay, so your password is the key to unlock your phone. So here now, from the specification, an address is the key to unlock or know the amount or the balance of a particular address on this contract. Okay, so that means you are going to define a mapping data structure. So this guy is going to map from address. Okay, so you can name your mapping. Okay, you can name me. I like to name my mapping. Yes, so address to amount. So given the address, you can actually know the amount or how much that account has. So I will name it balances. All right. So now, so it says it's going to return the balance of this account. So what we do is return. Remember, the name of our mapping is balances. So return balances. So what does this supposed to? Now this is the name of the mapping. Now we now need to pass the key. Okay, let me go back to the mapping and explain. So in mapping, this is the key. User is the key. That is, address is the key. This is the value. So what this means is that once you call these balances and pass in this key, which is the address, then you are going to get this value. Now the key can be anything when you are defining or working with mapping, but here the key is address. Okay, so that means once I call the balances mapping and passing address, which the address here is owner, definitely I'm going to get the balance stored that this user have on this contract, right? So that is that. So let's look at the other specification. Let's look at the transfer. So you transfer the amount of token to and must fire a transfer event. So we are going to create an event whenever we have the transfer function. So he said that this function should throw if the message caller balance does not have enough token to spend. So you can't spend more than you have. So before you spend or do any transfer, so they have to first of all make sure that you actually have more than you want to spend. So we are going to implement it. So this is just part of the security check, so that let's say if you have $100, you can't be transferring or spending $1,000. You get so that is just what this guy is trying to say. And whenever I call this function, you have to fire a transfer event. Yes, so Let's implement this guy. Okay, so now for you to transfer, you have to, for me to do a transfer to you, if I want to send money to you, I need to know your account number. And on my end, I need to know the amount I'm sending to you. So that is just what is happening here. So for you to transfer to anyone, so address to that is the recipient, then your value is the amount you are sending. How much are you sending to the person? You get now, but before that, remember, it says that there is a check here. There is a security check here. It said that the function should throw error message if the caller's account balance does not have enough token to spend. So that means we are going to implement some security check. Now in smart contract design, we have some design patterns. So we have what we call the CEI. So that is the check effect interaction. Check effect interactions. Get so this is telling you that before you do anything, you have to first of all check. So you have to first of all carry out a security check, then look at the effect before you now interact with maybe external contract or call a function for any external communication. So that is what we are going to do here. So the first thing we want to check, we want to make sure that the address the address we are sending to is not a zero address. You know, zero address is like a dead address. Yes. So we want to make sure that, okay, we are not sending to a zero address. So we use the require keyword or the require statement. So require that the to address is not equals to address 0. So stay with me, just follow through. Yes, let me walk you through how to let's build a contract, then I will go line by line to explain everything that happens in the line of the code. But let's implement the functions first. Yes, so I will not be explaining much at this stage. So if the address is 0, then so what this is going to, first of all, it will check that the address is not 0. So if it passes, it continues. But if the address is 0, it's going to give you an error. And once it gives you an error, this function will not go. So that means it will revert. So address not valid. So a 0 address is not a valid address on the blockchain. So this is one of the checks. So let's say write another check. So we want to make sure that the person sending this, okay, the person sending this actually have more than he wants to send. So whoever that is sending this or whoever that is calling this function is what we know as the message or sender. So if you call this function, maybe after writing this contract, if you call this function, you are the message or sender. So I want to check that the balance of whoever that is calling this function is greater than the amount or the value he or she wants to send. So I want to require that balance of, okay. Remember, we have the balance mapping. So balance of message or sender is greater. So this is the greater symbol. Let's just do some quick check. Greater symbol. Greater than. Let's be sure. Okay, this is greater than symbol, right? So require that the balance of message or sender is greater than. So your balance should be greater than the value. So you could as well do balance greater than or equals to value. But because of maybe some gas that might be incurred in the transaction, so I love to do balance is greater than value, so that first of all, your balance should be greater than value. Then maybe whatever that remains, you now use to pay for gas and the rest. Then if your balance is not greater than value, I will just tell you insufficient fund. You are a broke nigga. Get. So now, so after this check, okay? So after this check, when this check and everything has passed, okay, so this is the check first. So you need to first of all check. Okay, after the check, you now the another thing, yeah, you now do the interaction. So we should also, okay, just another security they see you might implement. Okay, I want to make sure that maybe user is not sending me zero value. Get so require that the amount like value is greater than zero, so that you don't send me zero or fake alert. You don't give me fake alerts. Get so value. Okay, let me just tell him or her increase amount. Get so stay with me. I'll go through this contract and explain everything. So these are some of the check we are looking at implementing. Okay, so now when this check has passed, so if at any point any of this check fail, the function will revert, so it will revert. So when everything has passed, you know, if I'm sending money to your account will be credited. That means there is going to be an addition to your account. Why me? They are sending it, there is going to be a deduction. So that is just what we want to do here. So first of all, we say that we subtract that value from the balance of MLG.sender. Then we are going to, we subtract the value. All right. Then the balance of the receiver, which is the to address, we increase it. So this is just telling you debit the sender but credit the receiver. Yes. Okay, let me quickly explain something here. You get, you know, what I just have here, balances of MLG.sender is the same thing as me writing balances of MLG.sender plus underscore. Okay, should be minus value. So these two lines of code, that is line 53 and line 55, they are doing the same thing. So, but line 53 is just the shorter way of writing it, you get. So let's go with line 53. All right. So we've implemented the transfer. Okay, and it tells us that when we transfer, we should emit an event. So let's define our events. So we should emit transfer events. So events are the logs that we emit. So these logs that are useful for the front end, especially when they are useful for front end to tell user what is happening under the hood. Get so by the time we'll be testing, you see the importance of this event. Get so emit event. So this is how you define your event with the event keyword. So emit the event, okay, address, okay, sender, okay, address sender. So I want to emit an event telling whoever that is getting the alert, okay, just the way when I send money to you, your bank sends you a message or an email telling you, okay, you receive some amount from this account. You get. So that's what we are just trying to do here. We want to emit a transfer event that will tell you who is sending it then address to, then in 256. So how much the person sends. Okay, so that is the event. So we've defined the event. Let's come down and emit the event. But before we emit the event, we have to, now the return type of this guy is success. So that means if everything is valid, you should return success. So that means success is equals to true. All right. Did I get the spelling of success correctly? Success is equals to true. Sorry, I'm defining it outside the function, so it should be inside the function. All right, so once the transaction is successful, then you have to emit event, maybe to tell whoever that is listening to the front end, or to tell the user what actually happened under the hood. So msg.sender, that is the sender or address form, then to whoever that is receiving it, then the value, that is the amount that was sent. So that is pretty much about, we've implemented a transfer functionality. Believe you me, this is one of the functions you should be playing a lot with. So it's very, very important that you actually understand what happens under the hood. Yet. So let's go back to our standard and see what we need to implement again. So we have the transfer form. So the transfer form, it said this method is used to withdraw token, allowing contract to transfer. So this just, let me give you a quick breakdown of what this is used for. Now, this function is used to transfer token on your behalf. What do I mean? Maybe I have 1,000. Okay, this token we are creating, this mass energy token we are creating, or MET token, you get. Now, I have 1,000 of this token, but I want to give you allowance. I want to give you privilege. Out of this 1,000 token, I want you to spend 100 on my behalf. So I am the address from, you are the address to. Yes, so you are spending it on my behalf. So I've given you that privilege, spend it on my behalf. Just like, okay, if you are my girlfriend, maybe I'll give you my credit card. Okay, so in my credit card, maybe I'll give you my credit card, maybe you are going to shop. Yeah, but I've already set a limit that you shouldn't spend more, that you shouldn't spend more than. Yes, so once I've given you that thing, you are spending it on my behalf because it will be deducted in my account, but I've given you the privilege. So another scenario for you to actually understand this transfer form is when someone gives you a check. You know, when someone is giving you a check, the person is writing the amount. So the money is the person's money. But that check he gives you is an authorization to withdraw that money from his account on his behalf. So that's just simply what this function does. And if you truly understand this function, it's going to help you a lot, especially when you be interacting with, for those of you that will go into DeFi and the whole of that, doing borrowing, lending, and the rest, you are going to make use of this guy a lot, doing swapping and the rest, you get. So let's see how we implement this guy. Yeah, but before we implement this transfer form, you know, before you can be able to transfer, before you can be able to withdraw from my account, okay, let's take the check scenario. Yes, before you can be able to withdraw from my account, so I have to sign the check. And when I sign the check, I have to date it and everything with my signature. So that means signing that check. If I give you a check without signing it, that means I've not approved it. If you take it to the bank, they will bounce it. So I have to put in my signature, which serves as an approver. So before we can be able to transfer, I have to first of all approve. So that this will bring us, okay, just stay with me. Stay with me. We are going to come back to this transfer function yet. So let's first of all look at approval, because you need to approve first before you need to have an approver first before you can be able to transfer. Now, the approve function, it says it allows the spender to withdraw from your account multiple times up to the value amount. In this function, if this function is called again, it will override the current allowance with value yet. Okay, so let's implement this approve function. So this just like me. In this check instance, I'm giving me signing that check with my signature. So that means, yeah, I've approved my babe, I've approved whoever to do this on my behalf. So, you know, the smart contract is code as law. Yes. So whatever logic you put into the code is what is going to give you. Yes. So it's code built into the law. So let's create the approve function before we now come to the transfer. Now, the approve function is going to take the address of the spender. So the person I'm writing, I want to spend, I want to withdraw the check, yeah, or I'm giving my credit card. So that is the address of the person, and the amount I want the person to withdraw my behalf. You get. Now this now brings us to another data structure in Solidity, which we call the mapping, though we have seen mapping before. But now we are going to create a mapping inside a mapping. Stay with me. I'll create a mapping. I'll explain it briefly here, but like I told you, once I'm done, I will explain everything line by line. So stay with me. Okay, so this is going to be a mapping of address. Okay. Okay, let me just name it so that owner to, let me name it so that you actually get what going through. To address spender, then to 256. So the amount or the value, whichever one you get. So let me just leave it as amount. Okay, so I'm going to call this guy allowances. Okay. So what this is trying to do is giving the address of the owner as key, map to the address of the spender as key. Then you can now get how many amounts or the amounts the spender is allowed to spend. Okay, you now get the amount the spender is allowed to spend. So that is just what we are going to do here. So we've created a mapping. So let's assign it to whichever value that's coming in here. So let me just change this guy to amount. Yeah, so that you won't be confused. So the name of the data structure we define there is allowances of who? Message or sender. So that means whoever that is calling this function is the owner. Okay, whoever that is calling this function is the owner. Now allowing the spender to now spend the amount. To now spend the amount. So this is just a quick walkthrough. Like I told you, I'm going to explain the code bit by bit. Just stay with me. Let me walk you through this thing, how it's implemented. Then I will go line by line to explain every bit of the code. Now, once this is done, you have to remember the return type here is success, which is good. So once this is done, you fire a source. You tell them if everything is successful, you return true. You get, then it says that, let's go back to the approve function. It says that it's going to emit an event. Okay, so it's going to emit an event called approval. Yes, so once this is done, once I've successfully approved you, then I'll emit an event called called approver to actually tell someone, okay, you've been approved to spend it. Okay, Mars have approved you to spend 20 tokens from his reserve. Okay, so let's define an event called approver. So approver address owner, okay, to address spender. So whoever that is spending the token, okay, then to the amount I've allowed you to spend. Yet, so this just the way your bank sends you credit, send you message if I send money to you, get. So the same way. So that's just what we want to do here. Okay, since you are giving someone approval, okay, after giving the person approval, notify the person, okay, this person are giving you approval. So that's just what event helps you to do. So you are going to emit this event. You emit approval. All right. So who is approving? Message or sender? Just as we defined in the event. So to who? To spender. So once you put the spender, it's going to give you the address and the value, which is amount. Just stay with me. I will explain everything line by line, but I want you to get the idea. Yes. So why are you saying spender not defined? Wait. Approve. Sorry, we made a mistake here. All right, so now we implemented the approve function. So once this function is called, whichever address you put at the spender, you've approved the person to spend on your behalf. Now let's implement another function. Okay, you've approved someone. So how do I even know how much you've approved me to spend? Okay, if I want to now check how much you approve me to spend, how do I do it? Yes. So that is where the allowance function now comes in. You get. So the allowance function, it returns the amount which sender is allowed to withdraw. So I've approved you to spend 100 of this token or 100 of my token. So maybe maybe you've deleted the message and you now want to go back to know how much you are allowed, how much I've approved you to spend. So that is now where you call this function. So that is what okay, let's implement it. I will still explain. So stay with me. Stay with me. All right, so approve. So here it's telling you that it's going to return. Now approve takes into parameter. So it's going to take the address of the owner and the address of the spender. So with this, you can actually know how much someone has been approved to spend. Right? So that means what you are just going to return is whatever that is stored in this allowances mapping. Now, remember, I told you that mapping is a kind of key value pair. So given the key, you can actually get the value. Now, in this mapping now, we have two keys. So that means allowances to address of the owner, then allowances to message of the, to the spender. So once I passing the key for the owner, passing the key to the spender, automatically I'll get the amount. And you know that in blockchain, addresses are unique. So no two addresses can be the same. So once I pass in my address and pass your own address, automatically I'll get how much I've allowed you to spend. Once I pass in my address and pass your girlfriend's address, automatically I'll get how much I've allowed your girlfriend to spend. Yeah, so that is just what this allowance function does. So it's going to return allowances, okay? Allowances of owner That is allowances of owner as key, then to allowances of spender. So once you provide these two key, then you are allowed to know the amount you've been okay, allowances. So once you pass in this, so automatically it's going to give you how much you've been allowed to spend, the amount that this address has been allowed to spend. So that is that about allowance. Now let's go back to the transfer form. Remember, if this transfer form is okay, let's go to the function. If this transfer form is somehow technical, because at some point you might be thinking, okay, why will I even allow someone to spend something on my behalf? But just the same reason why you give somebody a check is the same reason why we have this function. So if you are giving somebody a check, that means you are approving the person to do something on your behalf. Okay, so now we have the approve function, we have the allowance function. So now let's call this function to actually do that, because you have to first of all approve for me to withdraw from your. If you give me a check, before I can withdraw that check, it must have your correct signature. If your signature is not there, that means I can't withdraw, so I can't transfer from. So for this transfer form to work, so that means the correct signatories must be there, and those signatories are what we did in the approve function. Now let's now go back and implement this guy. So you can just take your time. By the time you read through this official doc, maybe twice, everything will make sense. But I will still explain this code line by line, yes. But let me finish creating all the method defined in the standard. Then I will go line by line and explain everything, yes. So that's pretty much about it. We have our ERC-20 token. So, sorry, I'm copying another thing. Okay, so transfer form. All right, so the transfer form is, so if everything is successful, so it's going to return boss, so it's going to return a success value, get. Now remember our check effects interaction, so our CEI pattern. Yes, so for me to actually call this function, so it has to do some check first, some security check. So one of the checks, so logic differs. Yes, so logic differs. If you're writing your code, you are the owner of your code, or whatever logic you give your code is what it's going to give you, get. So let's see the logic we built into this, you get. So first of all, I want to make sure that now this guy takes in 3 parameters. Okay, it has to take the address from, that is the owner, address to, that is the spender. So that person have approved, that account have approved to spend is this to now, this is the spender. Then the amount, which is the value. Okay, so, but first of all, I want to require that, okay, that this person that have approved to spend, that his address is not 0. So I don't want to send this thing to a 0 address. So this is just one of the check. So if this guy is a 0 address, just tell him not a valid address. Yes, so valid address. So this is one of the check. Okay, so this is one of the check. The another check you want to, okay, since I can as well check that address of the spend of this owner, which is from, is not a 0 address, so that you might not ghost me and send me money that doesn't exist. Yes, so I want to check that the address from is not a 0 address. Okay, then I also want to make sure that the value is greater than 0, so that you not give me fake alerts. So the amount or whatever you are sending should be greater than 0. Yes, so So I want to require that, all right, that value or amount, whichever one you like, call it, is greater than 0. If it is not greater than 0, just tell the person increase value. All right, so what else do you feel like we should check? You know, like I told you, the logic of your code is up to you. The logic of your code is up to you. Now, I think there is something we miss because I'm trying to think, okay, how do you know the balance of the owner? So that brings, okay, yeah, we did not implement this balance of functions. So this balance of, it returns the balance of an account. Okay, so we need to implement this guy. Sorry, I think we missed this guy. So this is the only way we can actually know the balance of the from, that is the balance of the owner. So we want to make sure that, okay, the balance has more allowance. Okay, let me just, okay, yeah, we implemented it. We implemented the balance of, I don't even remember again. So we want to make sure that, okay, like I told you, the logic is up to you. Just be flexible, take your time, think of, you know, for me, the best way to write a smart contract is to actually, as you're writing it, think like a hacker. So when you have the hacker mindset, it helps you to know the logics to bring in and the logics not to bring in. So that you write a contract that is secured. So what I want to do now, I want to make sure that the balance of the owner, okay, is greater than or equal to amount. So the balance of the owner is greater than or equals to amount. So these are just some security check. Okay, require that balance of, sorry, let me close it again. So balance of the form is greater than or equal to what? Value. If it is not greater than or equal to value, just say insufficient fund. You are a broke man. All right. So this, another security check you can bring in. Now, when you now have all these security check, then you should also make sure that, okay, that the value, that is the amount is less than the allowance. The amount, okay. So there are, okay, let's just put it. So there is no rigid, when I say there is no, this is not cast on stone, but just trying to make sure that there is no leak. So I want to make sure that the value, so value is less than or equal to allowance. Now, this is now calling the allowance function. Remember, there is a function we define called allowance. So it's calling this allowance function. So to make sure that, because this allowance function actually returns a unit telling you how much you are allowed to spend. So once I call this, I want to make sure that this spend actually still has that amount you want to spend. So if this check did not pass, it will revert. So I just want to make sure that allowances of, so that is address form, okay, address form to address to is, okay. Then if this guy did not pass, just tell them insufficient allowance or insufficient balance. insufficient balance, insufficient allowance, or insufficient balance, whichever one. Yes. And just to pass to tell them, okay, if your allowance is not this, okay, insufficient fund or whatever, then if everything passes, if the whole check works, so what do I now want to do? Since I'm transferring, remember we have an allowance mapping that is storing the amount. So that means once I transfer, I should decrease the allowance mapping by the value. So once I call this function, once the whole check are in order, so that allowance mapping, I should decrease it. I should subtract the value here from it. Then if I subtract the value from it, then I will go back to the balance of the owner. That is the balance of the balance of owner. That is the balance of the from address. I will also go back there and subtract the value. Then the balance of the to address, that is now the spender. The balance of the spender, what will I do? I will increase it. So these are just simple logic. This is what you know. Yeah. So these are just simple logic. So if everything is successful, I will now call the allowances, which is the allowances mapping of, remember, the first thing is the key. Okay, let me go back. And show you. The first key is address of the owner. The second key is address of the spender. So allowances of the first key. So the key here is from, so that is the owner, to the key of that is the spender. So once I've gotten this key, what do I need to do? I'll remove the value from there, because when I get this key, I'll now have the value. So what do I need to do? I'll subtract the value from there. Okay, so after I've done this, I'll go to the balance of the from address as well. All right. So what do I need to do? I will also subtract the value from him now, since he has spent his money. You cannot spend your money and still have it. You don't be thief now. Yes. Then I will now go to balance of the to address. Yes. So the guy receiving. So I will increase his value. So add value to what he has. All right. Now, when this is done, you also emit an event, emit a transfer event. So this specified in the official doc. So you emit event telling people, okay, this money has been set from this owner. Yes. So event, use it more on the front end than to underscore value. All right, so you emit this event once the transfer form is successful. All right, so this pretty much about it. Yeah. So now we've implemented all the methods specified in ERC-20 Token Standard using the EIP official doc. Okay, so now let's go. Let me take you line by line to still explain everything so that you understand how everything works more under the hood. So stay with me. I'll be right back. Let me take a cup of coffee. So I think I need to pause.